Permutation. A permutation is an ordered arrangement or sequence of objects from a set, where the specific order matters. The formula of permutation is NPR, or n factorial over times n minus r factorial. Here are some examples of permutation. The number 1 example is awarding medals. The problem is, from 6 runners, how many ways can gold, silver, and bronze medals be awarded? The total number of objects, or n, is 6, and the number of objects chosen or arranged, or r, is 3. The total number of objects, or n, is 6, and the number of objects chosen or arranged, or r, is 3. The formula of permutation is n factorial over times n minus r factorial is equal to 6 factorial over times 6 minus 3 factorial is equal to 6 factorial over 3 factorial. The factorial of 6 is 6 times 5 times 4 times 3 times 2 times 1 over the factorial of 3 is 3 times 2 times 1. Eliminate the 3 times 2 times 1 over 3 times 2 times 1 because they are the same. So let's multiply the 6 times 5 times 4. 6 times 5 is equal to 30. 30 times 4 is equal to 120. So there are 120 ways can gold, silver, and bronze medals be awarded. Explanation of this example number 1 is medal ranks are different, so order matters. The example number 2 is forming a 3-digit number. The problem is, how many 3-digit numbers can be formed using digits 1, 2, 3, 4 without repetition? The total number of objects, or n, is 4, and the number of objects chosen or arranged, or r, is 3. The formula of permutation is n factorial over times n minus r factorial is equal to 4 factorial over times 4 minus 3 factorial is equal to 4 factorial over times 1 factorial is equal to 4 factorial is 4 times 3 times 2 times 1 over 1. Eliminate the 1 because they are the same. So 4 times 3 is equal to 12 times 2 is equal to 24. So there are 24 ways can be formed using digits 1, 2, 3, 4 without repetition. Explanation of number 2 is different orders from different numbers. In example number 3 is about choosing class officers. The problem is, from 5 students, how many ways can you choose a president, vice president, and secretary? The total number of objects, or n, is equal to 5, and the number of objects chosen or arranged, or r, is equal to 3. The formula of permutation is n factorial over times n minus r factorial is equal to 5 factorial over times 5 minus 3 factorial is equal to 5 factorial over times 2 factorial is equal to 5 factorial is 5 times 4 times 3 times 2 times 1 over 2 times 1. Eliminate the 2 times 1 over 2 times 1 because they are the same. 5 times 4 is equal to 20, times 3 is equal to 60. So the answer is 60. So there are 60 ways can you choose a president, vice president, and secretary. So let's proceed or talk about combination. Combination. A combination is the act or result of joining different things, where the order of elements does not matter. The formula of combination is NCR, or n factorial over r factorial times n minus r factorial. Here are some examples of combination. The number 1 example is selecting questions. The problem is, from 10 questions, how many ways can you choose for questions to answer? The total number of objects or n is 10, and the number of objects chosen or arranged or r is 4. The formula of combination is n factorial over r factorial times n minus r factorial is equal to 10 factorial over 4 factorial times 10 minus 4 factorial is equal to 10 factorial over 4 factorial times 6 factorial. The factorial of 10 is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over the factorial of 4 is 4 times 3 times 2 times 1 and 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Eliminate the 6 times 5 times 4 times 3 times 2 times 1 over 6 times 5 times 4 times 3 times 2 times 1 because they are the same. So, let's multiply the 10 times 9 times 8 times 7. 10 times 9 is equal to 90. 8 times 7 is equal to 56. So, 90 times 56 is equal to 5,040. So, let's multiply the over. 4 times 3 times 2 times 1. 4 times 3 is equal to 12. Times 2 is equal to 24. Times 1 is equal to 24. So, therefore, the total is 5,040 over 24 or 5,040 divided by 24. And the answer is 210. The explanation of example number 1 of combination is the order of questions does not affect the selection. The example number 2 is picking fruits. The problem is how many ways can you choose 3 fruits from 8 different fruits? The total number of objects or n is equal to 8 and the number of objects chosen or arranged or r is equal to 3. The formula of combination is n factorial over r factorial times n minus r factorial is equal to 8 factorial over 3 factorial times 8 minus r factorial is equal to 8 factorial over 3 factorial times 5 factorial is equal to 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 factorial is 3 times 2 times 1. 5 factorial is 5 times 4 times 3 times 2 times 1. Eliminate the 5 times 4 times 3 times 2 times 1 over 5 times 4 times 3 times 2 times 1. Let's multiply. 8 times 7 is equal to 56 times 6 is equal to 336 over 3 times 2 is equal to 6 times 1 is equal to 6. So, the total is 336 over 6 or 336 divided by 6 is equal to 56. The explanation of example number 2 of combination is the order of choosing fruits does not matter. In example number 3 of definition is choosing group members. The problem is, from 5 students, how many ways can you choose 3 students to form a group? So, the total number of n or n is equal to 5 and the number of objects chosen or arranged or r is equal to 3. The formula of combination is n factorial over r factorial times n minus r factorial is equal to 5 factorial over 3 factorial times 5 minus r factorial is equal to 5 factorial over 3 factorial times 2 factorial is equal to 5 factorial is 5 times 4 times 3 times 2 times 1 over 3 factorial is 3 times 2 times 1 times 2 factorial is 2 times 1. Eliminate the 2 times 1 over 2 times 1 because they are the same. Let's multiply the 5 times 4 times 3 over 3 times 2 times 1. 5 times 4 is equal to 20 times 3 is equal to 60. Over 3 times 2 is equal to 6 times 1 is equal to 6. So, the total is 60 over 6 or 60 divided by 6. 60 divided by 6 is equal to 10. So, the answer is 10 ways. The explanation of example number 2 of combination is there are no position Anna, Ben, Carl is the same as Carl, Ben, Anna. Order does not matter. So, let's talk about their difference. Their difference. The basis of permutation and combination is meaning, order, use, formula, and example. The meaning of permutation is arrangement of objects, while combination is selection of objects. The order of permutation is order matters, while combination is order does not matter. The use of permutation is used when position or sequence is important, while combination is used when only choice is important. The formula of permutation is NPR equal to n factorial over times n minus r factorial, while combination is NCR is equal to n factorial over r factorial times n minus r factorial. Example of permutation is arranging students in a line, while combination is choosing students per a group. Another example. The basis of permutation and combination is focus, importance, result, common use, and question type. The focus of permutation is arrangement or order, while combination is selection or choice. The importance of permutation is position of items is important, while combination is position of items is not important. The result of permutation is different orders give different result, while combination is different orders give the same result. The common use of permutation is seating arrangements, passwords, while combination is committees, lottery numbers. The question type of permutation is in how many ways can we arrange, while combination is in how many ways can we choose.